Today's lesson will focus on the solution to the questions contained in Lesson 4. Lesson 4's topic was algebraic expressions dealing with division of a monomial by a monomial. Just to recap, when you are dividing, for example, a to the exponent 7 divided by a to the exponent 4, remember you have to write out in expanded form. So the expanded form of a to the exponent 7 is indicated here. Divided, you have your division sign. A to the exponent 4 is written out here. So this is known as the expanded form. And your final solution is a cubed, because the a in the top and the bottom cancel. So you get 4 a's on the top cancelling out with 4 a's at the bottom, and what remains is basically a cubed. So just remember, you're dividing two or more monomials. You divide the signs first, then you cancel out the constant factors as shown in the example below. Let us now proceed to the following questions that you were given. 5.1.1 to 5.1.10, and then these questions here. The solutions to all these questions are shown here. And what I'm going to now do is work out the detailed solution. For example, we'll start with question 5.1.1. So question 5.1.1, you were asked to divide a to the exponential 5 divided by a cubed. So again, by writing out a exponential 5 as in expanded form, you get a multiplied by a multiplied by a multiplied by a multiplied by a. As tedious as it sounds, it's very important that you understand this basic concept. So a to the 5, at the bottom we have a multiplied by a multiplied by a, which is 3. Because there's a division sign, you no longer add the exponents, you subtract. Therefore, this solution is a squared, because 5 minus 3 is 2. 5.1.5, you expand the top divided by m. So at the top we have m, which is actually exponent 7. And here, remember, it's m exponent 1. Because there's a division sign, it will translate to 7 minus 1. And 7 minus 1 is m exponent 6. Question 5.1.10 was a little different. Instead of just having variables, as in this question, you now have 12 and 3. The process, the method is the same. So the first thing you would do is 12 divided by 3 is 4. And then all the a's in expanded form translates to exponential 6 subtract 3. Similar to this. 6 minus 3 is 3. 4a cubed is your final solution. Then we get a question where you are not given a division sign, we're just given the symbol, the operation symbol. Now, how do we work out a question of this nature? Very simply, you do not have to write this out in this form. So pay attention to this. Because it's division, you know you're going to subtract. First of all, what's the sign of this number? The sign of this number is positive. So a positive multiplied by, a positive divided by a negative is negative. 25 divided by 5 gives you 5. Here's an A here. Here's an A here. Because they are equal in value, anything multiplied by itself is 1. So A squared divided by A squared is 1. B to the exponential 6 divided by B. What we could do here is make it like this. B to the exponential 0. So even though there is no B, we create one, because anything raised to the exponential 0 is 1. So B to the exponential 6 divided by B exponential 0 is just B exponential 6. Similarly, by doing that, and we know y to the exponential 0 is 1, so y cubed divided by y to the 0, which is 1, is y cubed. Moving on to exercise 5.2.5. A negative divided by a negative is positive. 16 divided by 8 is 2. 5, remember the exponent for p is 1, so 5 subtract 1 is 4. Q divided by q, or q squared divided by q squared is 1. And r cubed divided by r is r squared. Just one thing for you to remember. When a term like q squared is divided by q squared, you could also have this. Because remember, that is actually 2 minus 2, which equals 0. And anything to the 0 is 1. So your final solution for this is 2p exponential 4 r